In this video, we're going to try to compute the area between the two curves given by the functions y equal x and y equal the cubed root of x. So in this case, what we need to do is we first find where these two curves intersect. To do so, we have to solve this equation. X is equal to x to 1/3. Here we see that we have x is bigger than 0 in this case. And to solve, we raise everything to the power 3. We get x cubed is equal to x. And factoring by x, we see that we can write this one as x times x squared minus 1 equals 0. That means x is 0, x is 1, or x is minus 1. But since we are interested only for the positive values, so we have these two values, 0 and 1. Okay? We can also graph the two functions. So this is 1. So the cubed root of x looks like this. And this is the, let's call it g of x. And this is f of x, which is equal to x. And when we are trying to find the area enclosed between the two curves for x positive, we have to find this area here. Okay? And in this case, we have to integrate between 0 and 1. And therefore, our problem becomes the following. So we are looking for this integral that we're going to call I, that's between 0 and 1 of, so the cubed root of x minus x dx. So this is the area that we have to compute. Okay? We can rewrite this one in the following manner. X to 1/3 minus x between 0 and 1 dx. Okay? Now we're using the rule that whenever we have x to the power n dx, when we integrate, we get x to n plus 1 over n plus 1. Here we can think of 1/3 as some n, okay? And therefore, when we add 1, we're gonna have 3/4 times x, 4/3 minus x squared over 2 between 0 and 1, okay? And when we evaluate, for 0, we're gonna get 0, but for 1, we're gonna have 3/4 minus 1/2, that means 1/4. So our area in this case is 1/4 unit squared. Okay? Another thing before we finish this video is that we need to be able to see which one is bigger on this interval 0, 1. In this case, x is between 0 and 1. Okay? X squared, if we multiply by x, is less than x, is less than 1. X cubed is less than x less than 1, bigger than 0. Okay? So here we have this one here, x cubed less than x less than 1. So when we take the cubed root, okay, we're going to have the cubed root of x is less than the cubed root of x cubed less than the cubed root of x less than 1. Here we see that x is less than the cubed root of x less than 1, bigger than 0. Okay? That's why when we graph the functions, we have this one here. So y equals x is less than this. Okay? Because we assume that we are not using calculators. So this is how we get to see that x is less than the cube root of x on this interval 0, 1. Okay, and I think that's it. And this is the area is 1/4.